Okay, so in this video I'm going to have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2015, and I'm going to have a look at questions 1 and 2. So this is question 1 here, this is part A. So Mary threw a ball onto level ground from a height of 2 meters. So she started here and it went down, up, down, up, down, up, and so on. Hit the ground 5 times, 1, 2, 3, 4, 5 times. Each time the ball hit the ground, it bounced back up to 3/4 the height of the previous bounce. So the height from here to here is 3/4 of 2. So in other words, the first height here was 2 meters. So if you get 3/4 of 2, you get 1.5. So 3 over 2 meters. If you multiply 3 over 2, if you multiply 3 over 2 by 3/4, you get 9 over 8. You take 9 over 8, multiply that by 3/4, you will get 27 over 32. And if you take 27 over 32, multiply that by 3/4, you will get 81 over 128 meters. So I've written those in here, and that's really the first part of the question. These are the heights on any particular bounce, after any particular bounce. So let's have a look at part B then. Find in meters the total vertical distance up and down the ball has travelled when it hit the ground for the 5th time. Give your answer in fractional form. So the ball has travelled, first of all, 2 meters. So that's on the way down. So we'll call it the total vertical distance. So that's going to be equal to 2 meters anyway. And then it's going to be each of these doubled, because it's traveled 2 meters from here to here, then it travels up 3 over 2 meters, this distance here, and down 3 over 2 meters. So we've got to double that distance, double this distance, double this distance, and so on. So it's going to be 2 plus twice 3 over 2 plus 9 over 8 plus 27 over 32 plus 81 over 128. So when you do that, you get, well actually, you'll get 653 over 64. And remember, you have to give your answer in fraction form. Whenever you write down an answer, just go back and read the question just to make sure you're giving the answer in the way that they've actually asked you to give the answer. So we need this as fractional form, so 10 over 13 over 64. 13 over 64 meters. Well, this is fractional form here, this is fractional form as well. This is an improper fraction, if you like. This is a mixed fraction. So that's it really for part B. So for part C, if the ball were to continue bouncing indefinitely, find in meters the total vertical distance it would travel. So in other words, if the ball were to keep on bouncing continuously on into infinity, what distance would it travel up and down? Well, again, we've got 2 meters to start with, and then we've got to double each of these heights. So it's something similar to this up here, except now this series here, this geometric series in here, is going to go on forever. So let's just write that down. How would we write that? Well, our total vertical distance again is just going to be 2 plus twice all of these heights. So it's twice 3 over 2 plus 9 over 8 plus 27 over 32 plus, and so on into infinity. Now, how are we going to work that out? Well, we can see here that this is actually a geometric series, and in fact in the previous question this is a geometric series as well. So we could have done it, we could have just used the geometric series formula. Sn is equal to a times 1 minus r to the power of n over 1 minus r, just for this part here if you wanted to. But we've only got 4 terms here, so we could just add those up easily enough. Now, what we're going to do here then is we've got to use the some of the geometric series into infinity for this part here. So it's going to be 2 plus twice, and what we're going to use here is the sum to infinity formula here, which is just a over 1 minus r. So in this particular case, we know that a, our first term, is 3 over 2, and we know that or, then we have to multiply each of these terms by 3/4. So here we've got 2 plus twice. A is 3 over 2, and or is 3/4, so it's just going to be 1 minus 3/4 down here. So that's going to give me 2 plus twice. We've got 3/2 on the top and 1 minus 3/4, which is 1/4 on the bottom. So that'll give me 1 plus twice. Well, we're dividing two fractions here, so it's the top one multiplied by the second one flipped upside down. So that I'll just come over here now. So that's going to give me twice plus twice, 3/4, 12 over 2. So that's just going to give me, well, 12 over 2, this is going to be 6. 2 6 is 12. 12 plus 2 is 14 meters. So this is the total distance it would travel if it were to bounce indefinitely. That would be the vertical distance it would travel. Okay, so that's it for question 1. Let's have a look at question 2 now. Question 2 is just in one part here where we've got this cubic expression, or cubic equation actually, x cubed minus 3x squared minus 9x plus 11 equal to 0. And what we've got to do is solve this. So we've got to find out what x is here. Now we can see here it says write any irrational solutions in the form a plus b root c, where a, b and c are integers. So we know at some stage we're probably going to have to use the quadratic formula here. But let's start anyway. With cubic equations, what you've really got to do is guess the root, try it out and see does it work. So we're going to start, remember the roots have to be, in this particular case, if the coefficient here is 1, the roots have to be factors of the term independent of x. So the roots that we have to guess have to divide into this number here. So if we start with 1, well, 1 will divide into 11, so let's start with 1. X is equal to 1 and see what happens. Well, we get 1 cubed. We have a 1 squared here, we have 9 times 1, and we have 11 here, and we want that to be equal to 0. So let's see, is it? Well, 1 cubed is 1. This just gives me 3, this gives me 9, this gives me 11. Here then we end up with 11 plus 1, which is 12. Minus 3 minus 9 is minus 12. So we do end up with 0 is equal to 0, if you like. So that means then that x is equal to 1 is a root. So by the factor theorem then, x minus 1 is a factor. In other words, x minus 1 will divide exactly into this thing here without a remainder. So we can use that idea to find the other factors. So what I'm going to do next is, there are two ways of doing this, and I'll go through both methods, but I'm going to do it the long division way first. I'm going to take the x minus 1 and I'm going to divide it into the x cubed minus 3x squared minus 9x plus 11. So I'm going to divide that in. That will give me another factor up here, which will be a quadratic, but I can factorize the quadratic easily enough. So let's start. X into x cubed is x squared. Multiply the x squared by these two here, write my answer down here, so it's x cubed minus x squared. Put a line underneath and subtract. Okay, so let's see. Minus x cubed plus x cubed is 0. This minus times this minus is plus, so this is actually a plus here. So we have minus 3x squared plus 1x squared, that's minus 2x squared. Take the next number here, which is minus 9x. Let's bring that down. So we've got minus 9x here. And so we'll start again. So x into minus 2x squared is minus 2x. Minus 2x. Multiply this minus 2x by these two. So we get minus 2x squared and we get minus 2x. Put a line underneath and subtract again. So now we have minus minus, this becomes plus, so minus 2x squared plus 2x squared is 0. Minus minus, this also becomes plus. So we have minus 9x plus 2x. Have I got this right here? Oh, sorry, I've got this wrong. When we multiplied this minus 2x by this minus 1 here, which will actually give us a plus 2x here. This here should be plus. Okay, so that makes more sense. So this minus times plus here will give me a minus. So I have minus 9x here, minus 2x here, so that's minus 11x here. So again, just take this 11 here, bring it down, so this will give me a plus 11. And at this stage then what we can do is take this, divide this x into this minus 11x, that'll give me minus 11. Multiply the minus 11 by these two, write my answer here, so that will give me minus 11x, minus minus is plus, and 1 times 11 is 11, and we just subtract again, so this will disappear, well, we'll get 0 here and 0 here. So we have 0 remainder here, which means when we divided this x minus 1 into this cubic expression here, we got this quadratic here. So in other words, if I multiply the x minus 1 by x squared minus 2x minus 11, that will give me the x cubed minus 3x squared minus 9x plus 11. Now we still haven't got all our factors, our basic factors, in their simplest form anyway. This is in its simplest form, but I still have this x squared here, I have this quadratic trinomial here. So what I'm going to do is factorize this. So to factorize this one, if you look at it, it's going to be difficult, or very difficult actually, to just draw two brackets here and try to factorize it this way. And the clue anyway was in the question. The question said to give any this is 11 here. If we were to read it here, read the actual question, it says write any irrational solution in this form here, a plus b root c. So that means it looks like we're going to have to use the minus b formula, or the quadratic formula, to solve this here, or to solve x squared minus 2x minus 11 equal to 0. We got to solve that. So here we can see that a is 1, b is minus 2, and c is minus 11. So we can work out x here as being minus b, so minus 2, which minus 2, which is 2, plus or minus the square root of b squared, so it's minus 2 squared, minus 4 times a times c, all over twice a. So when you do this, you get 2 plus or minus the square root of 4, minus 2 squared is 4. Here we'll just get plus, anyway, minus times minus is plus, and then 4 11s 44. All of that is over 2, and when you do that, you get 2 plus or minus the square root of 48 over 2. Now, continuing on then, we get 2 plus or minus the square root of 48 is actually 4 root 3. So 4 times root 3 over 2. Your calculator should do that for you. If you just type this in and press equals, it should actually simplify it to 4 root 3. Now the other way of doing that, of course, is the square root of 48 is just square root of 3 times 16. So that will give me square root of 3 times the square root of 16, which is just square root of 16 is 4, so that's just 4 root 3. So that's another way of doing it if you want to do it manually. But anyway, at this stage, divide the 2 in here, you get 1. Divide the 2 in here, you get 2 root 3. So these are our other two roots. In other words, x is equal to 1 plus 2 root 3, or 1 minus 2 root 3. Now, so all of our answers then are, all our roots are, so x is going to be equal to 1. We had that from the very beginning. We tried x is equal to 1 and it worked. We've got 1 plus 2 root 3, and we've got 1 minus 2 root 3. Now, just the other way of finding this quadratic here, instead of doing the long division here, instead of doing this long division, another way of finding this quadratic, that's what I'm going to do now, okay? So what you can do is take your x minus 1. You know you have to multiply that by a quadratic to give you the cubic expression. So what was that again? X cubed minus 3x squared minus 9x plus 11. So what will our quadratic look like? Well, we've got to multiply this x by some term to give us x cubed. Well, it will have to be x squared. So the first one here times the first one here will give us the first one here. Now the last one here times the last one here should give us the last term here. So minus 1 times minus 11 should give me plus 11. But what about the one in the middle? Well, we don't know what that is, so I'm going to put in plus b times x. So it has to be an x to the power of 1 anyway, because it's a quadratic. So let's see if we can work this out. So what you can do here is multiply all of this out, and you'll get x cubed. X times x squared is x cubed. X times plus b is plus bx squared. X times minus 11 minus 11x. Now, is that okay so far? Yep, that's fine. So minus 1 times x squared is minus x squared. Minus 1 times plus bx is minus bx. Minus 1 times minus 11 is plus 11. And that has to be equal to this thing here. So let's just put this together then. We have an x cubed here. We have here an x squared, and we have here an x squared. So I'm just going to put those two together and factorize them. So that will give me b minus 1 times x squared. I've just put these two together, factorized out the x squared. Now I also have here an x, and I have an x here as well. So I'm going to put those two together. So I'll put down, I think I'll put down a minus here this time because they're both negative. So it allows me to put positive values in here then. So this will give me an 11 here and a plus b here, and I'll end up with an x here plus 11, and that should be equal to x cubed minus 3x squared minus 9x plus 11. Now if we look at the coefficients of our variables here. So the coefficient of the x cubed is the same here. We've got a 1 here and we've got a 1 here, so that's fine. We can see here the coefficient of the x squared here. So I'm just looking at this here, and the x squared here. What have I ended up with here? I've ended up with b minus 1 should be equal to minus 3. Because this is plus here, this is minus, so we've got to take the signs into account as well. So if we solve this here, we end up with b is equal to minus 2. Now, let's see, is that okay? We should end up here as well. Let's see, we end up here. If we look at this one here as well, we should end up with the same answer. I'm hoping it does. Let's see, we have a minus 11 plus b should be the same as equal to minus 9. So that would give me, we see, minus 11 minus b is equal to minus 9. That will give me minus b is equal to 2 by adding 11 to both sides. That will give me b is equal to minus 2. So I do get minus 2 for b, whichever coefficient I take. So this b here should be minus 2. And that is what we found up here when we found our quadratic. When we did the long division, we found that the b was minus 2. So it's just a different way. If you don't like doing this long division, you can do it that way. Okay, and that's it for questions 1 and 2.